Hello everyone. Today we are going to work on servo motors. A motor. Okay, let me tell you about servo motors. You will find three kinds of motors in your projects when you work with electronics or robotics. One kind of motor is used with wheels of robots, maybe wheels of cars. Okay, those are called as normal motors. Okay, DC motor. There is one kind of a motor called as stepper motor. Stepper motor is basically used for very precise kind of devices. For example, your printers. You know that your printer has some arm which is moving to left and right, right and left, and it is actually doing some printing and it does something at very precise places. So when we require a very precision kind of a thing, we use for something called as a stepper motor. The third one is a servo motor, which we are going to use here. And this servo motor is basically used for only 180 degrees kind of a movement. For example, the arm of a robot, the hand of a robot, the leg of a robot, which has a limited kind of a movement. Okay, 180 degrees only. So you understand what 180 degrees means. Now, what we are going to do now is going to use an Arduino. Yes, let me remove this. I just want this. We need an Arduino. We need a potentiometer. Yes. We also need a servo motor. Yeah, servo motor will be available in servo. So bring the servo also in. All right. What else do we need? Nothing else. Okay, we need. Okay, so this potentiometer is going to give input to the Arduino, and that is going to control how much of this angle is going to be used here. So what is going to be the movement of this particular servo motor? Okay, so we'll work on this now. Uh, we already know the three pins of a potentiometer. We know it is terminal 1, which is connected to the ground, terminal 3 connected to positive voltage, and wiper basically is giving input to the Arduino. Similarly, the servo is going to have one ground, one power, and one signal. This signal is basically going to tell the servo how much to move. All right. So let's work on this now. All right. Let's start our connections. Shall we have uh, a breadboard also? Let's bring the breadboard. Where is the breadboard gone? We'll use this one. Okay. Let's move this to one side so we don't need anything from here. All right. Let's now start doing the connections. Let me flip this to and let's bring it here. Uh, let's have the positive 5 volts connected here, the ground connected here, and color of this is black, color of this is red. Okay, that part is done. We'll pass on this voltage from here to here and this voltage from here to here, and let's color this black. So the connection is in both the rails now. Let us start giving our voltage. So we'll take ground basically connected to ground here and power connected to power here. So the basic part is done, majority part is done. Okay, now we need to connect this also. we will connect, let's bring them closer together, and let's bring this also closer. It's going to look okay now. All right. Let's connect this. So connection from this is basically to ground. This is basically to power. This is basically somewhere on the breadboard. Let's color this one as green and this one as black. Okay, the basic connections are done. Let's figure out which pin should go this. The signal should go to. The signal from here should go to here, and we'll connect the breadboard to somewhere. So, say, let's take only both are going to be analog. Both are going to be analog. So let's figure out. Uh, Analog input, I can take analog input from an analog pin, no problem. I'll take this color turquoise, and the output is going to be analog again. So we will take analog input because I'll use a PWM pin for it. Let's color this as pink. Okay, we have quite a circuit now. So we have the two devices, that is the potentiometer and the servo motor, both have getting power from the breadboard, and the signal is for the wiper is basically connected to A0. We should remember this, and the servo is connected to pin number 5. Let's start coding. Let's start coding and let's remove the extra stuff from here. Let's start off with the two pins. So one is called as pot pin. Again, we'll say pot pin is potentiometer is connected to pin number A0. Okay. So A0 it is connected to A0. And int let's call it as servo pin. This is connected to pin number 5. Okay, so both the pins have been set out. Okay, now we will do whatever we know now. So the things that we know about is between basically potentiometer. Yes, how to set up the potentiometer. I'll set it up with pin mode, pot pin as pin number, sorry, as an input. Let's start working on the servo now. How do we set up the servo? We have already told the computer that servo pin is pin number 5, but we need to set up the servo also. Okay, servo, for working with servo, there is a pre-created library present in the system, and we need to import that library. How do we import a library? Is by using hash include, and using the angular brackets, that is the less than sign, we specify the header file for the servo. This is called as a header file. Okay, so we need to include this. So this is the first line that you should actually put in over there. Next is I need to create an object. So I'm going to write things here. So this is to import the library. Here I'm going to create a servo motor object. Now, object is basically not a physical object but a software object. How do we do so? By creating, say, I'm going to call my servo motor here as my servo. Okay, I'm going to create a variable called my servo, and that variable is going to be of type servo. Okay, this servo has been actually, this is a new data type now. We used to work with int and float and string and so on. But this servo data type has been created somewhere in this library, so we don't need to figure out what it is. It is something which has been created. So we will say this data type, I'm going to create my servo. Okay, and semicolon, that's it. So my object is created. This is C++. Okay. Now I need to tell the computer that my servo is now going to be attached to the servo pin. Okay. So how do we do that? We write down the variable that we created, which was my servo, dot attach in bracket. Where is it actually attached? It is attached to the servo pin. So we specify this now. See, three basic things that we did. Number one was imported the library. Second is created an object. The object's name is my servo. And please remember, I'm going to use my servo everywhere whenever I use this servo now. So if I want to attach pin number A0 to the servo, okay, where is it? Servo pin is 5 actually. Okay, so if you want to can attach it to 5, so you say my servo dot attach in bracket servo pin. Servo pin has a value of 5, so this is basically the servo is attached to 5. So we have successfully done this. Now what do we need? I need to read information from the potentiometer. And how do I do that? I do it with analog read in brackets. I write pot pin, and this information is going to be stored in int var. Okay, let's make it. Now please remember, 5 is a PWM pin, A0 is an analog pin, and analog pins have values from 0 to 1023. Uh, the PWM pins basically have a value of 0 to 255. So when I read a potentiometer pin, what is going to happen? So what is going to happen is this var is going to have values from 0 to 1023. Now the thing is, my servo is not going to use 0 to 1023. I told you that servo basically uses value from 0 to 180 degrees. It basically goes from 0 degrees to 180 degrees, and that is the maximum. It does not even go to 255. So how do we map the values of 0 to 1023 to values 0 to 180? So how do we do that? We use another variable and use the map function. So we say var out is equal to map. What am I mapping? This is my basic value, that is var, which will have the value from 0 to 1023. So I'll say 0 comma 1023 comma. What should it be mapped to? It should be mapped to 0 to 180 degrees. That means the minimum and maximum of value of var is going to be 0 to 1023. But var out will have the minimum and maximum values as 0 to 180. So this is what basically I need. Now I need now to turn the servo that many degrees. For example, if it is 10 degrees, it should turn 10 degrees. If it is 90 degrees, it should turn 90 degrees. So how am I going to turn? I'm going to turn it by using the same variable that I used, my servo dot write, and the variable that contains the value, what is the angle now. Okay, I hope things are clear. Okay, so after this, maybe we'll put a delay of say 200 milliseconds, and let's see how things work. Okay, all right, let's start the simulation and see what happens. There is no problem here. The potentiometer is on zero. There is no movement in the servo motor. So let's see if I move this potentiometer, will this move? Oh my God, that is not moving at all. Let's see what went wrong. Okay, see, the problem is here that we have not actually connected the signal to pin number 5. The cable, the wire has been at the wrong place. All right, let's start the simulation again and see what has happened. Ouch, it has moved. Okay, so if I move this, you can see that the potentiometer, as far as it goes, and if it goes to the maximum, it has gone 180 degrees. Now let me tell you, it is not exactly 180, it goes as far as it goes. Okay, so when I return, you can see it is actually doing the return. If I go in again it moves. If I move it again it moves. Yes, okay. Now you have seen now how to take input from a potentiometer and turn something. For example, this could be a floodgate of a dam, and using a dial, I want to increase the flow of water. So basically, I want to open the dam a little bit like this. So dam is open little bit like this. If I wanted to open even more, I can open even more. So it is open like this. So basically what I am doing is I'm turning a dial, but what is actually happening in the output is the dam gate is open. Okay, the gate of the dam is open. All right, and that's it. So we have learned how to take input from a potentiometer and give the output to a servo motor. We also have learned how to use a servo motor. Let's see the usage of servo motor a little bit. First command that we did was to import the library. Without this thing, nothing will work. Okay, the system will not know what servo actually means without importing this library. So what did we do? First of all, we imported the library. Second, we created a variable of type servo. So we call this variable as an object, but as far as you are concerned, it is like a variable only. How do I tell the computer what pin is my servo attached to? So I'll use my servo. This is the same variable that you created here. Dot attach, in bracket, you can write down the pin number or the variable containing that pin number. You can see that loop is very small. So first you take input read the input using analog read from the potentiometer pin and store it into var. Now convert that var, which has a value of 0 to 1023, to 0 to 180, because that is the minimum and maximum angle of the servo. So we use the map function for it and store the new value in var out. So please remember, what has been read from potentiometer pin is actually stored in var, but because it is out of range for our my servo, so I have to map it now. So after mapping, the new value is var out. Var out will have minimum and maximum value as 0 to 180, and that is what we write to. So when we say my servo dot write, this will make the servo motor move in this angle. So if it is 90, it moves 90 degrees. If it is 60, it moves 60 degrees. So I hope things are clear. and I'll see you in the next video. Thank you for watching.